EDX Mechanics 1, Work, Energy and Power 1, Work and Energy, the work-energy principle. A body of mass m kilograms is being propelled by constant driving force F in a straight line. It accelerates uniformly from speed u meters per second to speed v meters per second over a distance of s meters. Ignoring any resistances, we can find a relationship between the work done by the driving force and the change in the kinetic energy. We know that F equals ma from Newton's second law, and we also know for an accelerating object, if the force is constant, the acceleration is constant, and we can use v squared equals u squared plus 2as. If we substitute a from one formula into the other, we get v squared equals u squared plus 2 f over m times s. And if we rearrange this formula, we get fs equals a half mv squared minus a half mu squared. So Fs is the work done by force, half mv squared minus a half mu squared is the change in kinetic energy. So the work done by the forces will equal the change in kinetic energy, and I would recommend as often as possible to use the work done by the force when you're working out a question. And this is known as the work energy principle. So a horizontal force of magnitude 4 newtons is pulling a particle at a distance of 5.5 meters across a horizontal floor. Find the gain in the kinetic energy of the particle. So we have the force and we have the distance, so we can work out the work done by the pulling force. So the work done by this pulling force is the force, which is 4 newtons, and it acts over a distance of 5.5 meters. So the work done by the force is 22 joules. And we know from the work energy principle that the work done by the force will be the change in kinetic energy, and here the change in kinetic energy will clearly be a gain. So the gain in kinetic energy must come from the work done by the force, so the gain in kinetic energy must be 22 joules of kinetic energy. In this example, we have a ball of mass 5 kilograms. It's rolled across a rough floor at a speed of 4 meters per second. The ball will come to rest at a point 4 meters away from the point of projection. Calculate the change in the kinetic energy of the ball. So we just have a quick diagram just to show what's happening here. We've got a 5 kilogram mass. It started with a speed of 4 meters per second. It ended up coming to rest, so that's 0 meters per second, and that happened over a distance of 4 meters. And the question says find the change in the kinetic energy. So the initial kinetic energy, that's a half times the mass 5 times the initial speed 4 squared. So the initial kinetic energy is 40 joules. The final kinetic energy is obviously 0 because it's come to rest, and we want the change in kinetic energy. So the change in kinetic energy will be the final kinetic energy take away the initial kinetic energy. So the important word here is the word change. The change in kinetic energy is we ended up with 0, take away what we started off with, which was 40 joules. So the change in kinetic energy is minus 40 joules. So if the change is minus 40 joules, that means that the loss in kinetic energy, if you wanted to think about that, the loss in kinetic energy would be a positive 40 joules. So the change in kinetic energy is minus 40 joules. the loss in kinetic energy would be 40 joules. So now we want to write down the work done by the resistance force. So if we just think about this as a quick diagram, we've got a 5 kilogram mass. It started at 4 meters per second. It ended up coming to rest, and it came to rest over a distance of 4 meters, and it came to rest due to this resistive force, which I'll call F. And the question wants us to find the work done by this frictional force. The work done by friction equals the change in KE. We know from the work energy principle that the work done by the forces equals the change in kinetic energy. And the change in kinetic energy, and the word change is important, the change in kinetic energy was minus 40 joules. So the work done by friction is minus 40 joules. You may come across questions that ask you for the work done against friction. The work done against friction would be plus 40 joules. The work done by the friction is minus 40 joules. As we can see there. So the thing to remember is the work done by the force equals the change in kinetic energy. Now we want to calculate the frictional force. So remember, we have this frictional force acting over a distance of 4 meters, and the speed went from 4 meters per second to rest. So now if we look at the work done by the friction, now the friction is acting in the opposite direction to the motion. So the work done by the friction will be a negative F acting for 4 meters. Don't forget, work and energy are scalar quantities. So we're not dealing with vector quantities here, but we are saying that the work done by friction will be negative and must be negative. So if the work done by friction is minus 4F, and we found previously that the work done by friction is minus 40 joules, then we can see that the frictional force, which is pointing backwards on the diagram, will be a backward force of 10 newtons acting backwards. In the next session, we're going to be considering potential energy.